प्रेजेंट हो जाइए, जिससे कि आपको एक बेहतर क्लास का अनुभव मिले। और यहाँ पर आप हमारे इस पर देख रहे हैं हम जो टॉपिक, महत्वपूर्ण टॉपिक है आर्किटेक्चर ऑफ एआई प्लानिंग, इसके बारे में हम आज डिस्कस करने वाले हैं। तो इन सभी पहलुओं को देखते हुए हम क्या करेंगे, हाउ इंटेलिजेंट एजेंट डिकोड इन्वायरमेंट, कैलकुलेट पाथ एंड डिसाइड व्हाट टू डू नेक्स्ट, शो द गोल सक्सेसफुल execution. तो फर्स्ट ऑफ ऑल स्टार्ट द इनिशियल स्टेट एंड सेकेंड इज गोल स्टेट, यानी इनिशियल स्टेट से स्टार्ट करके हम एक बेस्ट रूट तैयार करेंगे और उसे अपने गोल स्टेट तक पहुंचाएंगे। तो द आर्टिफिशियल इंटेलिजेंस नेविगेट्स द कंटिन्यूअस लूप्स। At the core of artificial intelligence is a rational entity operation within a world. The planning problem is bridging the gap between a known current state and a desired goal state through a sequence of calculated. So what the word is like that sensor percept, इसका इन्वायरमेंट क्या होता है, ये चीज आप देखिए। इसके इन्वायरमेंट में है स्टेट, हाउ द वर्ड इवॉल्व्स, व्हाट माई एक्शन डू, व्हाट इट विल बी लाइक इफ आई डू एक्शन ए। तो व्हाट एक्शन आई शुड डू नाउ, गोल्स पे एजेंट क्या करेगा, एजेंट अपने गोल्स को फोकस करेगा। तो व्हाट एक्शन आई शुड डू नाउ, एक्ट्रेस एक्शंस, प्लानिंग इज सर्च एंड लॉजिक, लर्निंग इज ऑप्टिमाइजेशन, प्लानिंग इज सर्च एंड लर्निंग, लॉजिक इज ऑप्टिमाइजेशन। इज मशीन लर्निंग data requires massive data sets to train weights. Mechanism black box optimization across a continuous landscapes. तो machine learning is output that probabilistic predictions and approximations, and AI planning is the start states and decision yes or no. तो possible state S is A and possible state action B, action A to action B. अब action A में yes और no, अगर S हुआ तो अप्लाई एक्शन A, अगर no हुआ तो अप्लाई एक्शन B, ठीक है। और एक्शन B इज पॉसिबल, तो S हुआ तो अप्लाई B इज possible, action apply B, and next branch no is next branch, prune branch. Now prune branch and intermediate state is yes, apply action B to S intermediate state to the goal state. Now knowledge relies on accumulated a dominion knowledge, mechanism heuristic search through state space, output highly understandable expression, probable action sequences. Now the complexity of planning depends on environment, deals, observability, determinism, डायनेमिक्स, टाइम्स। ऑब्जर्वेबिलिटी में आप देखेंगे, ऑब्जर्वेबिलिटी इज ए फुल्ली ऑब्जर्वेबल एजेंट सीज एवरीथिंग एज वर्सेस पार्शियली ऑब्जर्व्ड ब्लाइंड स्पॉट सेंसर नॉइसेस। डिटर्मिनिज्म इज determinist action have guaranteed outcomes versus stomatics actions have uncertain efforts. Then dynamics is statics word wait for the agents versus dynamic words change during deliberations. Instantaneous is the steps versus directive time and observations. Now, classical planning assumes a perfect, predictable words, fully observable, deterministic, statics, instantaneous. Now, domain model, a physics of the word object predicted available actions. Initial state is the first unambiguous starting facts. Goal state is the exact condition to achieve. Planner is that the output a rigid sequential plan of durationless actions. Now, graph plan prunes the search space using alternative layers. First step is that forward chaining. Build a planning graph alternating between possible facts and application actions. Step 2 is that mutes links. Track action that contradict each other. Cannot load state and drive structs simultaneously. Step third is that backward search. Once goals fact appear without mutex links, exact the previous sequences. Layer first and second layer is action and third is fact layer. Now the courses of dimensionality, why classical planning breaks. Mathematical terms, in a domain with a applicable action and a plan length of L, a classical planner generates a search tree is scaling at AL. Now, the reality for complex tasks like routing, a logistic fleets or robotics manipulations, searching every possible permitted action at every step requires impossible computational labor. The first step is start is 0 and second is the fractions 1 1 by 2, 1 by 2 is the 4 times. Now the hierarchical task network HTN, hierarchical task network, inject human expertise. The command tasks move stack of crates. And second is methods move crate 1 to temp pile. And method seconds move crate 1 to pile tiles. And take, put, drive and left. Take, put, drive and left. The advantage of HTNs rely on domains expert to define methods, drastically narrowing a planner's focus from infinite combination to no recipes. Methods of drastically pure the search tree. Compound task is that first methods first and methods seconds. तो मेथड फर्स्ट एस तो उसमें जो शॉर्टेस्ट रूट ऑफ द मेथड्स सेकेंड्स एंड सब टास्क टू solution. The classical complexity where A is equal to actions, L is equal to length. By grouping action into compound methods, ideal hierarchy exponentially reduce the nodes, generate trading setups, time for massive executions. Navigating the unknown when deals shift to uncertain. Now, observability is the perfect and faulty ones. One is the perfect and second is faulty one. So, continue journey planning, conformant planning. The plan is a decision tree reacting to sensor signals at runtimes. If running execute umbrella actions except time completes conformant plannings, the agent act blindly based on belief states, finding sequences that network regarding of the exact initial state. Escape complete. Now, prohibited planning MDP from rigid path to dynamic policies. The MDP models state as action A, transition probabilities P, and rewards policies over paths instead of the single sequence of action and MDP computes. A universal policy is defining the optimal action to take from any state the agent might randomly end up in. Execution is the solve via interactive algorithm value iteration to maximum accept rewards. State A and state B is rigid path, dynamic policy, action, environment, percepts. Now, POM DPS planning inside a cloud of probability. The challenges the environment is stochastic and partially observable. The agent never truly know its exact states. Believe that instead of mapping to concrete state, the agent maps action to belief states. Continuous probability distributions over all possible real world states. The cycle act, observe, updates, believes, acts. A general model for learning is highly uncertain environments. Now, the AI planners, playbooks, paradigms, matrix. First of all, worldview. Classical graphic plans states hierarchical STN task and probabilistic MDP believe and probabilities. Action outcomes classical deterministics and hierarchical deterministic usually. Probabilities uncertain schematics. Plan outcome classical linear sequences, hierarchical documentation tree, and probabilistic MDP universal policies. Key advantage classical domain independence, hierarchicals, exponentially faster search, and probabilistic robustness. Now, the hierarchy of hardness, computational complexity. First of all, first step PSPs, classical plannings, base camp first, accept times, next time is that contingency plannings and MDP branching actions, fully observability. Now, second base camp and expect space, conformant planning, acting blinding with uncertain outcomes. Base camp third, the submit undecidable, unrestricted STN planning, recursive methods and understands promotes POMDPS. Now, exponential expansion and complexity gradients. The convergence of planning and learning. The convergence of planning and learning. The reality is that the modern AI cannot be rely on search or data alone. The most advanced system integrated both. And this is the planning symbolics. Reinforcement learning is RL models via POMDPS. RL agent use deep neural networks to optimize the policies that classical planning defines mathematically. Now, action model learnings using ML to observe an environment and automatically reduce PDDL rules, removing manual human codings. This is the deep learning. Thank you. Keep learning.